Algebra 1, we're going to graph a compound inequality in two variables. So compound inequality, that means we have multiple inequalities, this inequality and this inequality. In two variables, that means they both have x and y in them. So since they both have x and y, I'm going to need a graph then that has both x and y in it. See if I can make it. Oh, this wasn't even close to a straight line. Boop, boop, something like this. And now I have these inequalities to graph. So this first one I'll do in this color. So 5x plus 3y is greater than 15. This is in standard form. So the way that we've practiced graphing that is that cover-up method or that intercepts method. If x is 0, let x be 0. Notice this becomes a 0, right? 5 times 0 is 0. And then we're left with 3y equals 15. When does it equal 15? When y is 5. We're just solving this when we plug the 0 in for x. And we do the similar thing for y. So y is 0, so I'm going to plug that in. 3 times 0 is 0. 5 times 3 is 15. So there's that part. So I know that this inequality, the boundary, goes to the point 0, 5, and 3, 0. So 3, 0, 1, 2, 3 is here. And 0, 5, 1, 2, 3, 4, 5 is here. And since this is strictly greater than, it's a dashed line. Try and make it kind of straight-ish. And technically, that's an open circle there, but that's not something that I would make a huge deal about. So then I have this this line that is my boundary, that is not part of the solution. And let's see, I'm going to test 0, 0 and see if it works. So if I plug 0, 0 into here, 5 times 0 is 0, 3 times 0 is 0. Is 0 greater than 15? It is not. So this would be shaded on this side. I'm not going to do the shading just quite yet. I'm just going to mark where it would be shaded. Because I have this other one too. These are connected with an and, so I need to know where they overlap. So I'll change the color and do this one maybe in this color. I didn't pick these to go together. This is in point slope form. So this goes through the point -2, -1, and it has a slope of 1/2. So -2, -1 is here. Slope of 1/2 would be over 2 up 1. And it is less than or equal to, so I can use a solid line because the boundary is part of the solution. And then now look, 0, 0 is on my line. I can't test 0, 0. So maybe I'll just test the point, how about 1, 2, 3, 4, 0, 4. I'll test this point right here. So I'm going to try 0, 4 and see if that works. So when y is 4, 4 plus 1, is that less than or equal to 1/2 times x is 0, 0 plus 2? So basically, is 5 less than or equal to 1? No, it's not. So this didn't work. Notice this is above that line, so that means this gets shaded below. So if this one gets shaded below and this one gets shaded above, since in an and statement, where do they overlap? They overlap right here. And so that shaded region is the collection of points that make both of these true at the same time, this compound inequality. So again, if I pick any point in this shaded region, like this point right here, 1, 2, 3, 5, 6, 7, 8, 1, x is 8, y is 1, plug it into here, plug it into 1 here, it'll make both those equations true at the same time.